Hi, my name is Manish Gupta, and in this video, I'm going to talk about ReConcile, which is how to do roundtable conference with large language models. So let's get started. How can we have these large language models collaborate and improve their reasoning? That's the main question, right? And that is why we'll study how can you organize them in a roundtable conference manner and try and improve their overall reasoning capabilities. Several previous papers have shown that these LLMs struggle with complex reasoning tasks, whether it is mathematical reasoning or common sense reasoning and so on, right? So now, if you really think from a philosophical perspective, in general, self-reflection is sort of an introspective process in humans as well, right? So you basically think about something and try to, improve your understanding about some topic or some issue and some problem and so on. The same thing is really relevant for models as well. It's an introspective process that allows models to improve their outputs by generating feedback from the model itself, right? So, and there are methods like self-refine which do that. So essentially, a model essentially, keeps ruminating over the same thought, and it turns out that over time it can actually improve its own output, right? However, it can suffer from degeneration of thought. So it can basically get into a high confidence wrong output, and then it basically just gets into this negative cycle. And therefore, people have come up with the methods like multi-agent debate, where the idea is to promote diverse thoughts using multiple models. So for example, here there are two models, and you essentially try to improve on the overall accuracy by having feedback from one model to the other. Sort of promotes diverse thoughts using wisdom of the crowd, or also called as society of the mind framework. Now, however, these particular models, which I previously proposed, whether just using those two models in the debate, or essentially also doing a debate along with a judge model at the side, right? If they all are just ChatGPT, which has been experimented in the past, then identical pre-training knowledge and identical model architectures leads to a restricted knowledge scope, right? So you can only do so much if the skill set of your members in the team is very, very similar. But in human teams, what people have observed is that collaborative processes such as brainstorming, group meetings, discussions, they help, right? Especially when the team has diverse skill set. And this is where this new framework called as ReConcile plays a role. So ReConcile essentially depends on multiple models and several rounds of discussions, roundtable conference between these multiple models. These models are heterogeneous. So one of them is ChatGPT, the other could be Bard, third could be Claude, and so on. And well, each of them will basically generate some sort of an output along with an explanation and the confidence level at every point in time. And then, they can actually then take convincing, examples from other models or their explanations and their output answers along with their confidence and try to improve their own reasoning for the next round. And they do several rounds of this kind until they basically, until they all agree or a max number of rounds has happened. Okay. So let's talk about this framework in detail. How does ReConcile work? So the way ReConcile works is basically shown on this slide. So let's start from here. We start with a question: is August a winter month for part of the world? Okay. And there are three models. There is ChatGPT, there is Bard model, and there is the third Claude model, right? So essentially, there are three phases in this ReConcile framework. The first one is this one, initial response generation. The second one is multi-round discussion. And the third one is final answer generation. So initial response generation, as the name says, you essentially start with the three models, give them the question, and also give them some convincing examples as part of the prompt. Now, what are these convincing examples? Well, these convincing examples are essentially just some examples where the model goes wrong, but the human can come and correct its understanding by giving a proper convincing explanation to the model. Okay. So in fact, in their particular case, so you could think of initial response generation as some sort of a few shot prompting kind of a framework where you essentially provide a convincing example of this kind. If you ask the model this question, is an ammonia fighting cleaner good for pet owners? And maybe the gold answer is yes, but the model came up with the wrong answer. Then the human can actually intervene by giving a good explanation. The human doesn't give an answer here, but gives a good explanation, a convincing. So therefore, it's overall called the convincing sample. So So for the initial response generation, each of the models work independently. They're given the prompt along with convincing examples, and essentially they generate some answers. They come up with some answers. So they don't just come up with the answers, but they also come up with the explanation. So there's an answer which is generated, explanation which is generated, and also a confidence score which is generated. As you see, all the three things being generated by each of those models. Now, once they've generated these triples, each of those models have generated these triples. You essentially get into phase two, which is multi-round discussion. As it says, it happens in multiple rounds. Two rounds are shown here, round one and round two. Okay. So in each of those rounds, each of those models, of course, work independently, but they're fed with something called as a discussion prompt. So this discussion prompt essentially includes the previous responses, these responses which are generated by all of these models. So it basically feeds in all of these responses. Now, of course, each response contains three things, as I mentioned here, the answer, the explanation, and the confidence score. Okay. And it also basically includes the convincing examples of other models, right? So remember, the convincing examples are different for different model because each model can actually make its own kinds of mistakes and therefore needs human intervention in that senses, or human explanation in that senses. Okay. So that's how our discussion prompt is generated. So more detail about the discussion prompt is actually shown on the left side. So you essentially, in the discussion prompt, you combine a few things as you see here. You combine the previous response. So the previous response is generated by all of them, all of the models, not just this model only, right? The confidence estimate. So, this guy said 60%, this guy says 70%. You basically feed in those confidence estimates from all of those models also, and then you group them. So essentially, you don't directly just feed in these three models ka response together, the response from these three models together as is, but you actually summarize them. So you would say that, two of the models said yes, and by the way, they had these explanations to support their answer, and this is how how much the confidence they have. But, one model said no, and this is the explanation for it, and that's the confidence score. So you group them. So you basically say that these two said yes, this one said no. Okay. And then, of course, you combine the convincing examples from all the other models, and that's basically your overall discussion prompt. Okay. So you see, discussion prompts are basically being fed to each of them, and then these models can come up with revised outputs. So they may change their final answer also, but in this case, you see, in this round at least, none of them change their final answer, but they can surely change their explanation. Okay. And as you see in round two, in fact, this guy basically changed its answer also, right? So not just the explanation, but also the answer changed. So this is how, over time, the models can actually improve on their reasoning and finally also improve on the overall consensus and thereby come up with more accurate answers. Okay. So as you see, these models are notorious for coming up with extremely high confidence, right? LLMs have been known to be very, very confident of their answers, even if they come up with the wrong answer, right? And therefore, in this particular work, the authors also propose that, if their confidence level is this much, then or rather, if their confidence level is what is mentioned on this right side, right? Map it down to a confidence level which sort of reduces their overall confidence, right? So if it is 1, then sure, keep it 1. But if it is from 0.9 to 1, make it like 0.8, or 0.6 to 0.8, make it like 0.3. So overall, reduce the overall confidence, right? To keep it under control. Okay. So which is what is being shown here. So at the end of every round, you can, of course, come up with a weighted vote across all of these models based on their confidence levels of their answers, and then come up with the final answer. So that's basically phase 3. You basically take the outputs from round 2, and that's your final answer based on the weighted vote that you get from each of those models based on their confidence scores. Okay. So here is a little more detail. We already discussed this on the previous slide, but an initial prompt, the phase 1 prompt looks like this. Each model gets its convincing examples. They use only four convincing examples. So that's the only human labor effort that is required. Just come up with 4 examples where the questions, questions where the model goes wrong, and then the human gives a good explanation, right? So as to change the model to start thinking in the correct manner, towards the correct decision. Okay. So you give the convincing examples, you give the test question, and give a prompt, basically asking it to come up with a step-by-step reasoning and also confidence level, right? So that's for the phase 1, right? This is for the phase 1. For the multi-round phase, this particular phase, multi-round discussion phase, roundtable conference phase, in that senses, you essentially have a discussion prompt where you take the convincing examples from all the other models. You also have, basically these convincing examples maps there. This picture is just from the previous slide, right? So, and then you have initial prompt, which is essentially just this thing, right? So initial prompt, and then you have this thing, carefully review the information from all the other models and then come up with your step-by-step reasoning, revised reasoning now, right? And then here you see this grouping going on. So you have like, the first group, the yes group there, and then the no group there. So this is the yes group, right? And then this is the no group. This is the no group there. Okay. In the yes group, you basically say there are two, agents that think the answer is yes, and then you basically tell, well, this is the reasoning, this is the answer, and this is the confidence. So essentially, you take the reasoning, answer, and confidence of the first agent, second agent, and then you basically have the guy, the no guy there, right? So essentially saying that the answer is no by just one model, and well, for that model, this is the reasoning answer and the confidence score. So how does roundtable conference thing work? I mean, does ReConcile really perform well? Well, they compare against several methods. So they compare against vanilla single agent methods, no multi-agent stuff here, right? Just one single LLM. They also compare with advanced single agent based methods where again there is only one LLM, but then it basically just tries to do self-refinement, self-consistency check, and or a combination of the two, right? Self-refinement basically just means that you use a single model and just try to, sort of do multiple iterations, so as to essentially help it come up with a better answer over those iterations. Self-consistency is about having the same model, but then multiple copies of the same model, and then, or rather, coming up with multiple answers, and then choosing the one which basically has the highest probability in that sense. Okay. Then they also compare with other single model multi-agent kind of frameworks like debate and debate plus judge. So these ones, remember, essentially, they just use models of the same type. So debate is with the 2 copies of ChatGPT, 2 copies of Bard, or 2 copies of Claude, and the debate plus judge is essentially 3 copies of ChatGPT with the 2 of them participating in the debate and 1 of them being a judge. Okay. And then the last one is, of course, ReConcile. So essentially, which is a combination of ChatGPT, Bard, and Claude. Okay. Now the report results on 4 different data sets as you see them here. So 2 of them, strategy QA and ECQA, are common sense reasoning data sets, and AQUA and GSM 8K are mathematical reasoning data sets, question answering data sets, right? So the results are shown with 3 rounds of iteration, and as you see from these results, of course, the GPT-4 results are the best. I mean, GPT-4 is really awesome compared to any of those. And notice that there's no GPT-4 here. It's just ChatGPT, Bard, and Claude. And then these are the results using ReConcile. And as you see, ReConcile is better than all the other baseline methods. In fact, even though GPT-4 is not considered as part of this roundtable conference in ReConcile, it actually gets you better results on strategy QA. In fact, it also gets you better results on ECQA. However, if you look at it, well, AQA, it gets you better results, but it's not significantly better given the large standard deviation here, right? On GSM 8K, well, it's not too bad. Let's call it, it's not too bad, right? So that's that. The other interesting part that they also experiment with is that how about including GPT-4 in the overall thing, right? And essentially in the entire framework. So essentially, as you see, if you include GPT-4 in the entire framework, essentially GPT-4 by itself was just 75, but then it gives you 89 points. So that basically means that the ReConcile framework helps GPT-4 also improve on its own predictions, right? So ReConcile is awesome because one, even without GPT-4 in the entire round table, it is able to get you better results than GPT-4 on 3 different benchmarks here, right? But if you start including GPT-4, it actually gets you even better results. And what is even interesting is that ReConcile also improves reasoning capabilities, not just for the team, but also for the individual agents themselves individually. Okay. Now, the last analysis is here at the bottom, right? It basically shows how this ReConcile framework perform with respect to different rounds. Okay, so as you see on the x-axis is the discussion round, and they actually do for 3 different rounds of discussion. So you start with the first initial phase, and then you do multiple rounds of discussion here. And 4 rounds are actually shown here. Okay, so what you observe is that, well, these things are for ReConcile and the debate model, debate with ChatGPT or debate with Bard. So what you see here is that the accuracy, if you look at it, the ReConcile model reaches, first of all, better accuracy. and then it reaches it much earlier. So if you look at this debate with ChatGPT, it takes like 4 rounds to reach the best accuracy. But ReConcile basically reaches that accuracy just with 1 round of discussion, and better accuracy than the other two models. Okay. This chart basically shows you, of course, discussion round, but what it shows you is consensus. So when do what percent of the samples reach consensus, right? And again, as you see, just after the second round of discussion, actually the consensus is reached by about 90 to 93% of the samples. There is a consensus reached, while other models actually struggle to reach consensus even after 4 rounds of discussion. Okay, even 90% kind of consensus. Okay, so in summary, in this video, I talked about this ReConcile framework. It's a very interesting, sort of framework motivated by the way we act as humans, right? So while trying to collaborate. So it basically is a multi-agent framework, multi-model framework in that sense, is for improving reasoning with diverse large language model agents, which are engaged in multiple rounds of discussion via confidence estimation and generating explanations that can convince other agents, right? So in this work, they basically showed results on multiple common sense and mathematical reasoning benchmarks. Now, there's a one little small caveat that, they basically showed results only using 100 samples. Now, that may or may not be really convincing, but well, they have essentially the standard deviations also reported along with the means. Okay. And they found that ReConcile outperforms prior single agent and multi-agent baselines on all 4 datasets, and it actually also improves on GPT-4 on common sense reasoning benchmarks, right? So, and specifically when GPT-4 was used as one of the agents, ReConcile actually improved its initial accuracy by 10 absolute points. That's actually very nice, right? And finally, basically, the interesting part about this way of doing things is that it leads to better consensus for sure, but also leads to faster consensus. Means it's a pretty efficient way of getting better results from large language models for reasoning kind of tasks. That's it. So thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage.